Assalamualaikum warahmatullahi ta'ala wabarakatuh and very good day. My name is Zamri Abdul Rahman. I am Vocational Training Officer at Fakulti Innovati Design and Technology, University Sultan Zana Abidin UNIZA. The title of my presentation today is a low-cost Benchtop 3-axis CNC milling machine using PCB Open Architecture Controller. This is the list name of the group member. The project led by Professor T.S. Dr. Saiful Bahari Muhammad. During this my presentation, I will share about our invention 3-axis CNC milling machine. This machine was created and the idea was developed due to manufacture and constraint during the learning process. Furthermore, the existing machines are not enough and the price is very expensive. Not only that, if the machines break down, it is time consuming and the cost of repair is also expensive. Thus, this machine invention was developed by evaluation several factors. This machine is made a small scale and it's open type frame structure design. We decide to use the standard PCB open source controller because to reduce manufacturing costs. List components are selected off the safe component, ready and available on the market. In the case of machine damage, it's also very simple and easy for maintenance and installation. Right now, we move to experimental test. It focuses into the design, configuration, and programming. One sample model has been chosen using SolidWorks. The 3D solid modeling design was saved into the step file format. From the step file, we apply it into integrated system and save it into TXT file. This interface was designed to further facilitate the transition from CAD to actual machining. This interface can avoid CAM module and bypass post-processor. Here, students can also understand programming learning by creating G-code. Once the G-code is generated, this file is transferred to the toolpath simulation that can see the perfect and any error present. When this G-code has no error, this file will be applied in Mesh 4 software to run in the machining process. Okay, for the next stage, the program will be tested using a 3-axis CNC milling machine developed for teaching and learning purpose. This machine was tested with 3 samples as the end product. It can replace the commercial expensive CNC milling machine in the market. Also, this product can be customized and applicable for any activity that requires 3D motion in the industry. For this slide, this shows a 3-axis linear movement design. It divides into the 3 parts. There is a x-axis, y-axis, and z-axis. Each axis has be different size and shape. Detailed drawing show important installation part, including linear slide array, lead box screw, drive motor, bearing, and other parts. Now we move to another slide that shows how this machine are fabricated, wired, and assembled. This machine is developed on small scale and portable type that easy to use. It also user-friendly because its CNC controller is using PCB open source as the main software. In terms of cost, this machine also inexpensive price that are of the safe component. The next slide display an illustration controller diagram module and also it illustrates the PC-based controller parameter configuration. For each setting parameter, it depends directly on the connection of the wire diagram. For the machine, we use full license Mesh 4 industrial software. Now, the slide shows the user interface for our integrated interface system IIS. This program is created based on the rule-based approach and developed using PHP software. This program is developed by extracting and referring figure recognition of the step file algorithm. This program will be translate the step file and automatically generate G-code and save them in the TXT file. Now, the slide shows the machining test and machining process for the experimental test. Let's take a look. The short video that have been prepared during the experimental test. The material used for the experimental test is high molecular weight polyethylene HIM PE. There are 3 different shapes of the sample. There is sample 1, sample 2, and sample 3. The parameter setup of this machine test spindle speed is S 30,000, feed rate F500, and depth of cut is -10. The experimental test use plot size is 100 mm head times 100 mm weight times 24 mm thickness. Also, this machine test is used for fluid and milk cutter 10 mm of diameter size. Now, we move for another slide. This slide presents the invention of our product, that is the DIY Benchtop 3-axis CNC milling machine using PC-based open architecture controller. This project is titled Fabrication of a Low-Cost Benchtop 3-axis CNC milling machine using open source controller for teaching and learning purpose. This project received funds from the University Internal Grant Pre-Com that amounted to Ringgit Malaysia 30,000. This machine already patented for the intellectual properties notification under registration of industrial design through the CRIM UNISA. For the next, our invention product is Integrated Interface System (IIF) for toolpath generation. This project is titled Integrator of Step using data structure for interface development environment. This project also received funds from the Fundamental Research Grant Scheme (FRGS) that amount to Ringgit Malaysia 19,500. This product already patent filed for the intellectual property notification under registration of copyright through the CRIM UNISA. Here, some current journal and writing that have been made. Already submit for publication to JFAS. Other one is submit International Journal of Engineering and Technology, and also submit on International Conference on Green Design Manufacture. Okay, now we come to the last slide right now. For market and commercialization potential. This product can meet the need of higher education institutions in technical and vocational courses that offer technical or manufacturing courses, effectively replace high-cost conventional machine and improve student learning. This machine also can use for small-scale production and medium-sized enterprise. This machine operates with 3 axes, so it's applicable and can be customized for any activity that require 3D motion like laser cutter, router, automatic welding, rapid prototyping, and so on. For the invention, the invention already signs an agreement of Memorandum of Understanding (MOU) that exchanged between UNISA and Casa Armada. So that's all. Thank you to all involved and contribute to this particular project and research. Also, thanks a lot for the judge of our presentation product. Assalamualaikum and thank you.